Hi guys, welcome to ENS181 Engineering Mathematics. In this video, I'll be discussing the introduction to differential equations. Here's the chapter contents for our discussion. So we have definition and terminology, initial value problems, and differential equations as mathematical model. First, we define what is a differential equation. So it is an equation which contains derivative or differential. So, based by the definition, kung ang equation natin consists of a derivative or differential of a given variable, then it is a differential equation. So mostly, we will see this term dy over dx or y prime, or we can also use the subscript notation u sub x. So this three notation is used to write a derivative within a differential equation. So here we have series of examples and we're going to identify if it is a differential equation. So dito sa example A, we have this is a differential equation because of this term, which is the derivative of y with respect to x. Same dito sa B, we have quantity y plus t dy plus y dt. So we have two variables, y and t, and we have this term dy and dt as the derivatives. Hence, this example B is a differential equation. For C and D, we have a partial derivative of variable s and z with respect here sa letter C. S is being differentiated with respect to variable t and variable x. So we have two terms here, which is a derivative of a function or variable. So this example C is a differential equation. Same here sa example D natin, we have second partial derivative of C with respect to y plus partial derivative of z with respect to x. So this term or this notation is used to represent a partial derivative. Hence, example D is a differential equation. For letter E, we have y prime plus p of x times y equals to q of x. So the derivative term here is this y prime, or the prime notation for our differential or so for our derivative. So this one is a differential equation. Well, for example F, we have 3x squared y minus 2y plus 6x minus 9 equals to 0. So in this example, we don't have any term that contains a derivative. Hence, this one is a algebraic equation since we don't have any derivative terms on the equation. So what is independent and dependent variable? Independent variable, it is when an equation involves one or more derivatives with respect to that particular variable. And dependent variable is a variable whose derivative occurs. So we have example here, L d squared I over dt plus r di over dt plus 1 over ci equals to 0. So this equation is used to solve an RLC circuit. So the independent variable here is this variable t. And our dependent variable is I. This L, R, and C are just parameters which is constant given in the circuit. So here we have a partial differential equation. So the dependent variable here is u, and the independent variable we have x, y, and z. So tandaan lang natin dito to identify the independent and dependent variable is that in a Leibniz notation written in this form, the variable on the numerator is the dependent variable, and the variable in the denominator is our independent variable. So it means the variable in the numerator is being differentiated with respect to our independent variable on the denominator. Now, one classification of a differential equation is an ordinary differential equation. So an equation contains only ordinary derivatives of one or more dependent variable of a single independent variable. So if you notice here, we have one or more dependent variable, but for differential equation to be ordinary, we only have single independent variable. So example, here we have dy over dx plus 5y equals to e raised to x. This one is an ordinary differential equation because we only have single independent variable, which is x. Next, we have this one, dx over dt plus dy over dt equals to 2x plus y. So we have two derivative terms in this equation. And if you notice, we have two dependent variable, which is x and y, and we only have one independent variable, which is variable t. So this one is an ordinary differential equation. As long as the entire independent variable on an equation is only one, then it is an ordinary differential equation. Next, we have partial differential equation. For partial differential equation, it contains partial derivatives of one or more dependent variable of two or more independent variable. So now, our independent variable must be greater than 1 to be called a partial differential equation. So we have here example, a second partial derivative of u with respect to x plus second partial derivative of u with respect to y. So we have two terms here that contains a derivative terms. So the dependent variable is u, and it is being differentiated with respect to two independent variable, which is x and y. Same here in our example, we have second partial derivative of u with respect to x equals to second partial derivative of u with respect to t minus 2 times 2 partial derivative of u with respect to t. So we have three terms that have a derivative, and we have one dependent variable, which is variable u, and two independent variable, which is x and t. So since our independent variable is greater than 1, then this differential equation is a partial differential equation. Now for order of differential equation, this is the order of the highest derivative that appears in the differential equation. Titingnan natin within our equation kung ano yung pinakamalaking order of derivative. So for example, here we have a dy over dx plus 2xy equals to e raised to x minus 1. So the derivative term here is this one, dy over dx, and it's just a first order derivative because we only differentiate variable y with respect to x once. So this one is a first order. For example B, we have 4t sine 2y dy plus t to the 4 cosine y dt. If you notice here, our derivative is dy and dt, and it is only a first order. So this one is first order differential equation. Now here we have a partial differential equation. So if you notice here, we have two terms that contains a derivative, and this one is a second partial derivative of variable z with respect to y, and this one is partial derivative of z with respect to x. So the order for this one, ang kukunin natin is yung highest, which is 2. So this one is a second order differential equation. Now here we use a prime notation. So for prime notation, if your order of derivative is greater than 3, then we represent it by a numerical number enclosed in a parenthesis. So if you're going to read this example letter D, pagbasa nito is we have 6th derivative of y plus 2 times the 4th derivative of y minus 5 times 2nd derivative of y plus y equals to 0. So, if we're going to identify the order of differential equation here, so this one is the derivative term that consists the highest order. So this one is a 6th order differential equation. Now for letter E, we have d squared y over dx squared plus 5 times the quantity of dy over dx raised to 3 minus 4y equals to e raised to x. So the order of differential equation here is 2 because this one contains the highest order of derivative. Even though itong dy over dx natin is naka-raised by the power of 3, still, this one is a first order. This one is first order and this one is second order. So, entirely, this equation is a second order differential equation. Now, for the degree of differential equation, so if an ordinary differential equation can be written as a polynomial in the unknown function and its derivative, then its degree is the power to which the highest order derivative is raised. So, titingnan lang natin kung mag-identify tayo ng degree of differential equation is that first we look to the highest order of derivative within the equation and we check the power or the exponent of that highest order derivative. Here in example A, we have dy over dx plus 2 times the quantity d squared y over dx squared raised to 3 equals to e raised to x plus 1. So first natin i-check dito is the highest order derivative. So the highest order derivative here is d squared y over dx squared, which is a second order derivative. Then we check the exponent. So this derivative is raised to power of 3. Hence, this equation has a third degree differential equation. So for this example letter B, we have 4t sine 2y dy plus t to the 4 cosine y dt. So if you notice here, we only have dy dt which is raised to 1. So this one is a first degree. In example C, we have second partial derivative of z with respect to y plus partial derivative of z with respect to x equals to 4 sine x plus 2y. So check natin kung saan yung highest order of derivative. So in this example, we have this term. So highest order derivative, we have second order derivative, and this one is only raised by power of 1. Hence, this is a first degree differential equation. So in this example, we have 1/2 times the 6th derivative of t plus quantity 2 times the 4th derivative of t raised to 7 plus e raised to negative t equals to 0. So, if we check here, hanapin natin yung highest order of derivative. So, the highest order derivative here is this, and this one is raised to 1. So, this is a first degree differential equation. Even though itong ating 4 or itong 4th derivative of t is raised by 7, but the entire equation, the highest order is the 6th derivative of t. And the exponent for 6th derivative of t is just 1. So, meron tayong first degree differential equation. Same here in our example E, we have d squared y over dx squared plus 5 dy over dx raised to 3 minus 4y equals to e raised to x. So, first natin tingnan is yung term with the highest order derivative. So, this one. This one has the highest order derivative, and the exponent of this one is just equal to 1. So this is a first degree differential equation. So i-check muna natin within the equation kung saan yung may highest order, then i-check natin yung exponent no highest order derivatives in the equation to identify the degree of differential equation. Now for linearity of differential equation, so given an nth order ordinary differential equation is a linear if an equation is a linear in our dependent variable y and its derivatives. So we have y, y prime, y double prime to nth derivative of our dependent variable y. So it means when the ordinary differential equation is linear, we have this expanded form of our differential equation. We have a sub n of x times nth derivative of y with respect to x plus a sub n minus 1 times to d raised to n minus 1 y over dx raised to n minus 1 up to a sub 1 of x dy over dx plus a sub 0 of x times y equals to g of x. So diminishing yan from nth order until sa 0th order of our dependent variable. Magiging linear lang siya if our coefficient of a derivative is purely function of our independent variable. Then our dependent variable must all be in a linear or first degree. This one, they should all be on first degree because y is our dependent variable. So we have two properties here of linear ordinary differential equation. First is the dependent variable and its derivatives are of the first degree. So it is linear differential equation, and the coefficient of our derivatives or the derivative term are at most on x or constant. So this a sub n of x must be function of x. This coefficient must all be function of x or constant. Then we have a linear differential equation. So example here we have dy over dx plus 2 times d squared y over dx squared raised to 3 equals to e raised to x plus y. So our dependent variable here is y. And this one is being raised to the third power. So this is a non-linear differential equation. Example B, we have y prime plus p of x times y equals to q of x. So our dependent variable here is y. And if you notice, this one is first derivative of y and the degree is 1. And in this part, we have dependent variable y, which is the degree is also 1. Since our dependent variable and its derivative are on first degree, hence this is a linear differential equation. So for example C, we have y times dy over dx minus 4x squared y equals to e raised to x plus 1. If you notice here, our dependent variable is y. So this derivative is on the first degree. Same here for this dependent variable, nasa first degree tayo. But for this example, the coefficient for this derivative, we have a y. So this one is non-linear because the coefficient here is in terms of our dependent variable. So this one is a non-linear differential equation. So as long as ang dependent variable natin is on a first degree or wala siya nakalagay sa logarithmic function or trigonometric function, then the differential equation is linear. So sample ng logarithmic, so for example, we have log of y prime plus 2y equals to 0. This one is nonlinear because of the term log of y, because our dependent variable here is y and it is on a logarithmic function. Same rin if we have sine of y plus y double prime equals to e raised to 2x. So because of this term, our dependent variable is within a trigonometric function, then this one is a non-linear differential equation. So ganun ang pag-identify natin sa linearity ng differential equation. So in this part, we have practice quiz where you are going to classify the given differential equation. So I want you to pause this video and try to answer or classify the given differential equation based on the choices. So we have 5 items here and you have to answer it on your own. And the answer is right over here for you to check. So that's it for introduction to differential equation, the classification of differential equation. So next video, we'll be discussing solution of ordinary differential equation. So I hope you learned from this video. See you on the next discussion.